everybody. Welcome to our class here at CXCMathtutor.com. Today we're going to be looking at how to calculate function values. The function values are important to calculate. They form a part of the larger topic, relations, functions, and graphs, and whether on the multiple choice paper or on paper 2, you may be asked to calculate the value of a function. Certainly, if you're going to be drawing a graph, you will most likely be working out the values that will form the range, and those values, if they're not worked out properly, will not give you a correct graph. For this part of the topic, we're just asked to calculate individual values for a function. So here, if we're going to calculate f of x given this function, f of 3 given this function, and g of 4 given that function, our target word, what we use is that we substitute. So we substitute whatever number we get into the function and do our calculations, and whatever result we get, then once we do it correctly, we know that we have arrived at our correct value. The aim is that after completing these questions and going through that, you would have developed enough competence to be able to successfully do any kind of question that you may see on a CXC paper that requires you to calculate a function value. So let's begin by looking at how to calculate f of 3 and g of 4 using these. So we're going to substitute. So using f of x and finding f of 3, wherever x is in the f function, we're going to put 3. So let me write f of x here. F of x is equal to x plus 1 over 2x minus 5. And we're simply going to substitute 3 here and 3 there. Now this will give us 3 plus 1 over 2 times 3 minus 5. And this is going to give us 4 over 6 minus 5, which gives us 4 over 1, which is just 4. So f of 3 is equal to 4. And what that means basically is if you put 3 into this function as a domain value, you're going to get 4 as a range value. So if you were going to put it on a mapping diagram for argument's sake, and you put in 3, then the resulting value that you're going to get over here is 4. That's essentially what it's saying. Or if you should write it as a coordinate, then you put in 3, you get out 4 as a coordinate. All right, so let's look at the next one. G of 4 means we're going to put 4 into this function wherever the x is. So x is here and here, so 4 goes here and here. So g of 4 becomes 2 times 4 minus 5 over 4 plus 1, which gives us 8 minus 5 over 5, which gives us 3 over 5. So g of 4 is equal to 3 over 5. Let's practice with some more examples and see how this works out. Here we have a function. We are asked to calculate f of negative 6. So we're going to put negative 6 into this function. So we're going to write 3 times negative 6 minus 2, which gives us negative 18 minus 2, and that gives us negative 20. So the value for f of negative 6 is negative 20 here. In this question, to find f of negative 4, we simply drop our negative 4 here and here. So we're going to have negative 4 squared minus 14 over 5 times negative 4. Now when we square our negative 4, the answer is going to be a positive 16 minus 14 over negative 20, which gives us 2 over negative 20, which can be further simplified as negative 1 over 10. So f of negative 4 here gives us the result of negative 1 over 10. In this question, this function is called a rational function. There's a reason for this. Rational function. A rational number is a number written in the form a over b. Any number that can be written in the form a over b. Of course, b can't be 0. So we need to make that say that. So any number that can be written in that form is a rational number. And this function is written in fraction form, hence we call it a rational function. Now, rational functions can be tricky because of their denominators, but we'll get to that in a little bit. Let's work out this value first, h of 0. So h of 0 means if you're dividing and you get 0 for the answer, it means that 0 was in your numerator. That's the only way you can get 0. So what we do is that we set our numerator to be 0. Our numerator is 3x minus 1. And we solve it. 3x minus 1 is equal to 0. Set it to be equal to 0 because h of x is 0. The value is. So we have now 3x is equal to 0 plus 1, and 3x is equal to 1 here. So 3x divided by 3, which tells us that x is 1 over 3. So if you put 1/3 into this function here, then 3 times 1/3 will give you 1, and 1 minus 1 is 0. So you'll be dividing 0 by something else, which is not 0. So the answer turns out to be 0. You could also write your question as h of x, which is 3x minus 1 over x plus 5 equals 0. And cross multiply it. X plus 5 times 0 is 0. 3x minus 1 times 1 is equal to 3x minus 1. So you end up with just solving the numerator, and the result is what we have here. But for the second part of the question, it says what value of h of x is undefined, meaning what number should you put in there, and if you put that number in there, you cannot get a value. So undefined. Right here it says unidentified. It should be undefined. If you want this thing to be undefined, then recall that for something to be undefined means that you have to be dividing by 0. This is what it means to be undefined. Undefined because when you divide by 0, you cannot get an answer. There's no meaning for it. There's no answer for it, hence undefined. So what we need to do here, because we want a 0 here in the denominator, we take this denominator, which is x plus 5, and set it equal to 0 and solve it. So we say x plus 5 equals 0, therefore x is equal to 0. Take away 5, which means that x is negative 5. So here, if we wanted the function to be equal to 0, it means that the numerator would have to be 0. Or the whole function for that matter is equal to 0. When you work it out, you end up in this case, because it's a rational function, that the numerator is 0, and we solve the numerator being 0 and get the value of 1/3. If you want it to be undefined, then you must make the denominator 0. Solve that simple equation that results, and this is your value. So if you put this value in this function, then you're going to get negative 5 plus 5. You're going to get a 0 in the denominator, and once you get a 0 in the denominator, you will not be able to get an answer, which means that the thing is undefined. Let's move on. Here, we want to calculate g of 2, and to calculate g of 2, we simply put 2 into the function here. So we're going to find g of 2, meaning we're going to say 2 plus 2, because we're substituting the 2 for x. 2 plus 2 over 2 minus 5, which gives us 4 over negative 3. And that's simply done. If we want to find the value of x for which the function is not defined, it could also be stated as what value of x cannot be included in the domain of the function. Then it means the same thing as this. And what we do, since we want the value that makes it undefined, we take the denominator and we set that denominator to be 0 and solve it. So we have x is equal to 0 plus 5, and so x is equal to 5. And what we're saying is if x is 5 and you put it in here, then what you're going to have is 5 plus 2 in the numerator over 5 minus 5 in the denominator, and you're going to have 7 over 0. And this has no answer, hence undefined. So the value of 5 would make this function undefined or not defined, and cannot possibly put in the domain if you're trying to draw a graph for that function. There wouldn't be a value there, and there'd be a break in the graph, or a discontinuity, as we tend to call them in math. Here we're going to be looking at composite values. Now, composite values are where you have more than one value being asked for. So let us ignore this part for now. Let us ignore this part for now and look at g of 2 and f of g of 2. So we have our two functions there. So if we're going to calculate g of 2, then g of 2 means that you're going to put your 2 into the g function, which is x over 2. So we're going to put 2 over 2. So g of 2 has a value of 1. Now the other part of the function says calculate f of g of 2. F of g of 2. And if you're wondering what that means, remember that you just calculated g of 2. Here, g of 2 has a value of 1. So if we replace g of 2 with 1, what it's actually asking you to do is to calculate f of 1. And to calculate f of 1, what we do is that we put 1 into this function, which is 1 squared plus 3, and that will give us 1 plus 3, which is 4. So the composite function value f of g of 2 is equal to 4. Now let's make something general about this. If you're asked to calculate a composite value, say you're given the functions f of x and g of x, and then you're asked to find f of g of some number a, then first thing you're going to do is that you're going to work out g of a. Find that value, and after you find that value, you substitute the value for g of a into the first function f. So if we label them as first function and second function, then our idea is to work with the second function first. So 1, compute value for second function, and then we put that value into the first, and you solve it again. We're going to practice with some examples so you'll be able to see it worked out. So if we have these two functions, f of x and g of x, and we're going to find g of f of 3, then the first one we need to work out is f of 3. So let's prosecute f of 3. F of 3 means we're going to put 3 into this one. So f of x is equal to 2x minus 1. We're going to find f of 3 would be 2 times 3 minus 1, which is 6 minus 1, which is 5. Now that we have the value for f of 3, we're going to put it into our g function and essentially find g of 5, because f of 3 is equal to 5. So g of 5 is going to be equal to half of 5 plus 2, which gives us half of 7, and half of 7 is 3.5. Here, something similar. We have h of k of 4. So our first order of business is to calculate k of 4. And k of 4 means 4 plus 2, which gives us 6. Now, having gotten our k of 4 to be 6, h of k of 4 means now h of 6 because k of 4 is 6. And h of 6 means we're going to put 6 into this function, which is 1 plus 3x. So we're going to have 1 plus 3 times 6, which gives us 1 plus 18, which is 19. Another example, in this case, we are looking at a different idea where you are asked to find a value, and above the value you see f negative 1a. It's read as f inverse of a. Or you may be asked to find what value of x would make f of x equal to some other value. These two expressions in functions mean the same thing. And I need you to understand that very clearly, that if the question is written as this, and if the question is written as this, they mean the same thing. So what it's asking you is, what value should you put into this function so that when you work it out, you get 17 for the answer? So what we do is that we take the function and work it in reverse. So we take the function and say, all right, f of x is equal to 4x minus 3. So we take that 4x minus 3 and make it 17. And once we solve this, we'll get an answer. 4x is equal to 17 plus 3. 4x is equal to 20. And therefore, x is equal to 20 over 4, which is 5. Now, if you put 5 into this function as your x, then 4 times 5 is 20. And 20 minus 3 would give you back the 17. Let's try it again. What value of x should you put into this function so that when you work it out, f of x is equal to 10? Now we'll do the same thing. So we let f of x, which is 4x minus 3, be equal to 10. And we solve that, saying f of x is equal to 10 plus 3. F of x is therefore equal to 13, and so x is equal to 13 over 4. So if we put 13 over 4 into this question and work it out, then our answer would be 10. If you want to try it and see, then if we put 13 over 4 into it to find f of 13 over 4, then 4 times 13 over 4 minus 3, we divide out that, gives you 13 minus 3, which is 10. And notice that they're different. F of 3 is very, very different from f of negative 3. In this question, if you were working out f of 3, all that you would do is substitute 3 into that function. So f of 3 would mean 4 times 3 minus 3, which would be 12, take away 3, which would give you 9. But f inverse of 3, let me correct that. I wrote f to the minus 3 there. Let me correct this thing. So f to the minus 1, or f inverse of 3, would be worked out as what number should you put into this function so that you get 3 for the answer. And to get that value, we take the function 4x minus 3 and make it equal to 3. So 4x would be equal to 3 plus 3. 4x would be equal to 6. And x would be equal to 6 over 4, or 3 over 2. So please note them that these two are very, very, very different. F of 3, that f of 3 is not the same thing as f inverse of 3. They're very different, and they're done in very different ways. To find f of 3, all that you would need to do is to substitute your 3 into the function f of x and get your value. But to find f inverse of 3, you need to do it in reverse to say, what number do I put into the function to get 3 for the answer? And to get that value, what we do is that we equate the function to the number here and solve that equation that results. Let's try it again and see if we can find some more. Here it says if f of x is equal to 4 minus 5x, then what is f of 4? So what number should you put here to get the function to be equal to 4? So we're going to take that function, 4 minus 5x is equal to 4. What number should we put in there? Now we have a negative 5x here, so is equal to 4 minus 4. Negative 5x is equal to 0. And the x is therefore equal to 0 over negative 5, which is 0. So if you put 0 into this function, then your value is going to be negative 4. In this one, if you put what value should you do to get 4 for the answer? Then we say x plus 2 over x minus 5 is equal to 4. So we're going to solve that by cross multiplying. X plus 2 is equal to 4x minus 20. Reorganize our equation. 4x minus x is equal to minus 20 minus 2. And therefore 3x is equal to minus 22, and x is negative 22 over 3. So if positive, that's actually positive 22 over 3. So if you should be actually solving this, then you would make the function equal to 4 and solve that equation. So we cross multiply x plus 2 times 1, we get x plus 2. 4 times x, 4 times 5 gives us 4x minus 20. Reorganize the equation. 4x minus x and negative and positive 2 here plus 20. And there we go. All right, let's look at another example. And this is our last one. So here we have a function machine. It says input x multiply by 3, then add 5, and you get your result. So using the information to write a formula for y. So whatever you get at the end is equal to 1. Put x in. When you put x in, multiply it by 3, and then you add 5. So this is the answer for that. And here, if you put 4 into the thing, then what happens? So you put 4 in, then you multiply 4 times 3, and then you add 5. So put 4 in, you're going to get 4 times 3, which is 12, and 12 plus 5 gives you 17. Or if you want to use a formula here, then 3 times 4 plus 5 would be 12 plus 5, which gives you 17. So the second section is 17. And it says here, if the number 8 was input, it was output, what was the number? So taking our function here, 3x plus 5, if 8 was the output, then what did you put in? So we have to solve this equation. Let's say 3x is equal to 8, take away 5, and 3x is equal to 3, and x would be equal to 3 over 3, which is 1. So if you put 1 in there, you're going to get out 8. If you put 4 in there, you'll get out 17, essentially. I hope this was useful for you, and I wish you best of luck as you go through your paper and practice and develop your proficiency and efficiency as you continue to do your studies.